going to talk about diode and PN junction. First, let's talk about this diode. We can draw a schematic of diode like this, and this means the plus means we call this plus anode, and minus we call it minus like cathode. So and plus and minus will be called like this. And if we apply the voltage to diode, the IV graph will be drawn like this. So if a voltage will be applied, this graph will go higher exponentially. So based on this graph, we can know this IV graph is non-linear. Then let's talk about this PN junction. If we doped something to the material, after doped, we can get a material like this, look like this. So in this material, we can know about this NP junction, PN junction. It means based on this PN junction, we can change the characteristic of semiconductor, so we can know about this PN junction's characteristic. So let's talk about PN junction more specifically. Let's talk about built-in potential first. Built-in potential means the potential difference between n-type Fermi energy and p-type Fermi energy. So it is when we make the device, it is exist for naturally. So yes, it is decided by the material of device. So every device has built-in energy inside. So based on this built-in energy, we can draw a PN junction diagram, Venn diagram. In this part, for electron cannot jump up this barrier because there are built-in potential in here. However, an electron cannot jump up because it doesn't have enough energy to jump up. So energy concentration will be look like this, and energy concentration gets smaller to it when it goes to the right side. So you can see this energy concentration gets smaller. However, similarly, whole concentration it looks like same. So it is very high, it is very big at the right side. However, when it goes to the left side, it will get smaller. So yes, we can know about the electron and hole concentration on this diagram, and in this case, it is thermal equilibrium state. So this Fermi level is drawn in the same level. So you should know that if that state is thermal equilibrium, you should draw a Fermi level in the same level. So yes, then let's talk about the specific diagram of before this diagram. In the left side, it means this part, this left part. There exist fixed charge and carrier coexist. So it is that electron and hole are the number of electron and hole is same. So this right side is also electron and hole is the number of electron and hole is same. So in these two region we call space region, space charge region. So, and the important thing of this region, they exist a mobile carrier in here. So yes, in here. However, we should look more specifically, more attention in the middle side. There are, in this region, the recombination is very high. The happening is very high. So there are no carrier in here. So there are only fixed charge exist. So yes, the everything is depleted. So we call this region depletion region. So we should use this depletion region for many things. So this width means depletion width. We call depletion width. Then let's talk about the applying voltage to PN junction. This is PN junction and we can apply the voltage. If we apply positive voltage, it means we call forward biased. However, if we apply negative voltage, it means reverse biased. So how we apply the voltage can decide the PN junction's characteristics. So let's look the difference of PN junction. This is the if we apply the forward biased, it means we apply positive voltage. So this means that yes, after we apply the positive voltage, this depletion region will be smaller than before. A black graph is the before and blue one is after graph when we apply the positive voltage. The potential junction potential will be reduced after we apply the positive voltage. So the depletion width will be smaller than before. And let's look this graph. This graph means after when we apply a negative voltage. This red one is after graph. Yes, then if we apply the negative voltage, this graph will be changed like this, and depletion region of width will be bigger. So junction potential will be more higher than before, so this width will be more larger than before. So this is very important characteristic of semiconductors. So we should use these functions to make efficient semiconductor. So today we talk about diode and PN junction. Thank you for watching my video. Bye.